Pushpak, I and my friend Hamad prepared a presentation on topic lubricants. In this presentation, we will discuss about what is the definition of the lubricants and what are the requirements, functions, and what are the types and also the properties of the lubricants. Definition of the lubricants. Lubricants is the substance used to reduce the friction between the two moving surfaces. The process of reducing between the two moving surfaces is called as a lubrication. A lubrication, it is used to reduce the friction between any two moving parts. That like example for any cars, buses, etc. In requirements, what are the requirements? Should not undergo any decomposition or oxidation at high temperature. It should not undergo any decomposition or oxidation and should not corrode the part of machines. That means it should not damage to the parts of the machines. Should not be toxic or harmful to the operating personnel, and it should not any harmful to the person who is using the lubricants. Should be cheap and readily available. It should be in low cost and very easily available to everyone. Should have high viscosity index, very flash point, very fire point, low carbon density, good ion lubricants. There are three functions of lubricants. First one is it reduces the friction and wear between the moving parts. The main function of the lubricants is used to decrease the friction and also heat between the moving parts. It acts as cooling by dissipating the friction. Dissipating means it is decreasing the frictional heat developed in the moving surfaces. It prevents entry of moisture, dust and dirt between the moving parts, and it is also mainly useful in without entering the moisture, dust to react with the moving parts. And then we will discuss about what are the types of the lubricants we have. First one is the thick film lubrications or fluid film lubrication or hydrodynamic lubrications. And the condition for the thick film lubrications is it is worked out under conditions of low load and high speed. The thickness of the fluid film at least 1000 angstrom, and the coefficient of the friction is low as the 0.01 to 0.03. For example for the thick film lubrication is rotation of shaft with respect to the stationary bearing. Okay, next we will discuss about the boundary lubrications or thin film lubrication. It works out the condition at high speed and low load. The thickness of the fluid film lubrication should be less than 1000 angstrom, and it should react with the metal surface and forms thin lubrication. The coefficient friction is such around 0.05 to 0.15. The examples for the thin film lubrication or boundary lubrications are vegetable oil, that means oleic acid. Another one is stearic acid. Compound formula is C17H35 COCH, and we will discuss about the structure of the stearic acid. This is the structure of the stearic acid exactly have. There will in stearic acid there will present two groups. One is carboxylic group COH, and it is present on the top position of the lubricants, and another group is alkyl CH3, and the distance between the two edges of this lubricant is 2 nanometer approximately. And then we will discuss about the another last type of lubricants, extreme pressure lubrication. It works on the condition of the high load and high speed. The special additives like chlorinated esters are used along with these lubricants. The special additives, that means which will increase the power of the lubricants, such as chlorinated esters, which is used with the lubricants. This metallic compounds possess high metallic points. This type of lubricants will have high melting points and serve as a good lubricants under extreme pressure conditions. Classification of the lubricants. The lubricants will be classified into three types: solid lubricants, liquid lubricants, and semi-solid lubricants. Example for the solid lubricants are graphite and molybdenum disulfate. And the examples for the liquid lubricants are the olive oil, palm oil, whale oil, and tallow oil. And the examples for the semi-solid lubricants are grease and vaselines. And now we will discuss about the properties of the lubricants. The first property of the lubricants are the viscosity. Viscosity is the measure of the resistance to flow on its own. Viscosity is the measure of the liquid to flow on its own, and it can be measured by using the redwood or Seibold viscometer. This is the diagram of the Seibold or redwood viscometer, which is used for the measuring the viscosity of the fluid. Then we will discuss about next viscosity index. The viscosity index, it is the increase in the temperature. It is defined as the average decrease in viscosity the average viscosity with respect to the rising temperature between the 100 degrees centigrade Fahrenheit to 210 Fahrenheit. For this calculating the given oil, we should fix the two oils, which two oils are that are Gulf Coast oil, and another one is the Pennsylvania oil. The Gulf Coast oil, which we know the viscosity index fixed as 0. For Pennsylvania oil, the viscosity index fixed as 100. By floating a graph between these two oils, and for our given oil, we'll float a graph. The graph will appear is this like, where x-axis has temperature and y-axis have viscosity. The V will be calculated of a given oil will calculate using formula L minus U by L minus H into 100. Now we will discuss about the flash point and fire point. Flash point, it is the lowest temperature at which the oil gives enough vapors that will flash. If a small flame is brought near to it, it is called as a flash point. And fire point, it is the lower temperature at which the oil gives enough vapors that will burn continuously for at least 5 seconds. It is called as a fire point. It can be determined by using the apparatus, sky matrix apparatus. The main significance of this flash point and fire point is knowledge is useful for providing the safeguards for transferring the lubricants from one place to another place. This is the physical appearance of the apparatus, and this is also the diagram of the Pennsylvania apparatus. Now we'll see another slide about the cloud and pour point. Cloud point, when the oil is cooled under the specified conditions, the temperature at which the oil becomes cloudy, it is called as a cloudy point. Then we'll pour point. On further cooling, the temperature at which oil gets seized, and that means it could not flow, and that is called as a pour point. The significance, it is useful for the at lowest temperature for knowing about the lowest temperature of the lubricants at which it can be works for operating without any risk of using the emissions. A good lubricant must have a low pour point. A pour point lubricants can be lowered by the lowering the viscosity of oil by dewaxing, and another dewaxing means removing the wax from the lubricants. Now this is the physical appearance of the thin plus oil. Now we'll discuss about the solid lubricants. Solid lubricants are under the following situations. There are three conditions where operating temperature is and load is too high. The solid lubricants are used in the case of high temperature and high load, and where contamination, the dust particles should be avoided, and that means it should not damage to the machine particles. Where combustion of the lubricants must be avoided, and that means the lubricant should not burn at high temperatures also. Graphite, it consists of the graphite structure is a hexagonal arrangement, and they are bonded with a strong covalent bonds. The adjacent layers are held together by van der Waals forces. The distance between the two adjacent layers is 3.14 angstrom, and it poses low coefficient of friction, and layers can be slide or other with a little friction also. It is very soft to touch and not flammable. It is dispersed in oil. When it is dispersed in oil, it is called as oil lag. It is used for in oil compressor oil and food processing equipments. And when this graphite is dispersed in water, it is called as aqueduct. This is used in the internal combustion engines. Another example is for the solid lubricants are molybdenum sulfate. It is like in a sandwich-like structure. The two layers are in two layers between there is a molybdenum, and above two there is sulfur atoms. These atoms are together by strong covalent bonds and together held by the weak van der Waals forces. This is the structure of this is the structure of the molybdenum disulfate, where these two are the sulfur atoms, and this is inner orange color is the molybdenum. The distance between the sulfur and molybdenum is 1.54 angstrom, and these are the another examples for the lubricant example. This is the lubricant series, and this is another example for molybdenum disulfate, and it is worked out on the conditions of heavy emissions, and also it can be oxidized above 800 degrees.